Hi, everyone. This is a new session in our Entity Intelligence project where we develop a library, a .NET library, an open source, standardized test-driven library for the .NET community to be able to integrate a capability into their existing systems where people can use natural language to consume content from a database using AI without, the trick here is that without any leakage of information, without any exposure of information to the OpenAI external APIs. And we had a quick kind of tiny session, over the weekend with Milan Toncic, where we basically talked about the database side of this. So there's the database side, there's the AI side, and we decided that he's going to kind of take care of the database side. He's going to be working on that for a while. I don't know if he has any open PRs yet, but I need to check. But what we're going to continue to do today is the processing aspect of this. And processing services are very interesting because when you're basically, let me just kind of give people kind of high level what's a processing service in the standard compliant community, and then we'll dig a little bit deeper about the implementation of this. So you must, at some point in time, have come into a situation where you basically have a simple database like this, and then you went and built, something that talks to this database. Let's say a lot of people call it data access layer, data access object, whatever the case may be. We call them brokers because it's much more generic. And then let's say we put a service inside of this one. So this is what we call a foundation service. So let's say if in here, if the capability that you set up in here is something like select all students, right? So this is just a capability that is very primitive. It just talks to a database and selects all the students, speaks the language of the medium that it's working with. There is also another one in here. Let's say select, let's say update student like this. And maybe there's another capability here that says insert student, right? So primitive, basic operations, no problem there. Hey, Hassan. Hey, Mustafa. Nice to meet you. Okay, so I have these capabilities. And then we basically said there's a foundation service, which is basically going to, reflect all of these with a little bit of validations on top. Hey, Gregory. So in these, we'll basically say retrieve all students, right? So this is retrieve all students like this. And maybe another capability here would be modify, watch how the language is changing from one medium to the other. It's like moving from one town to the next, and people have their own kind of, accents and whatnot. So when the engineer is looking at a method, they know immediately where it's at without seeing any other details. Like DNA, it's baked naturally into the systems that you're working with. And let's say this is called modify student. You see how I'm changing language again, and then add students, right? Okay. What do we do when we want to do something that's called a higher order business logic, something like an upsert student, meaning that I'm going to give you an object, and if this object exists, then update it, but if it doesn't exist, then create it, right? Where does that logic belongs, right? I've seen a lot of people will go up in here and basically do it in here. It'll be like upsert student like this, right? Which is terrible because now your foundation service is doing way beyond just primitive operations with validations on top. Now your foundation service is now doing higher order business logic that requires a higher order of validation, and you're basically losing your the speciality or the concern of that particular medium, right? Even worse, I've seen people do it in here, right? So they put all that logic in a broker level where they can't possibly test drive it because that's your data access layer. And the data access layer now is carrying business logic. So the whole application becomes, this chaotic system that is very hard to maintain and work with, especially think about an enterprise application that's like 1 million lines of code and you're looking at, things that are hacked up together this way. So this basically gives birth the right way to do this, or the standardized way to do this, is to basically create something called processing service. And this processing service is just another concern, another capability that will say I will orchestrate between the primitive operations on that particular service. So if a foundation service is working with retrieve and modify and add, I will be the orchestrator between all of these. And I will work with each and every one of these and leverage them to be able to produce literally a higher order business logic, right? Something that is, noticeable and understandable by the business. So in essence, processing services are nothing but orchestrators of primitive operations from their counterparts in terms of foundation services. All right. What's this has to do with anything? Why am I talking to you about this? Because when we are building this entity intelligence project, building a system for AI, there are services in that system, a processing service that needs to bake in the statements that we want to send to AI, right? This is the service that will be doing the higher order business logic, the service that will go and say, there is a primitive operation, that will go and hit the AI and give me back some answers. Okay, that's our foundation service. But there's something that needs to live on top of that that gives it these prompts and kind of bake these prompts for it. That's what this processing service is for. All right. So let's, Omar, unless you have any questions, let's kind of go ahead and kind of build the interface for this. Let's see what that looks like, right? So I'm going to go, let me increase the resolution here real quick. Here we go. Usually with standard compliance systems, the higher you go in the chain of services, the more likely you are to start doing a little bit more thinking and a lot less, working on, particular what I call it just grunt work. You're basically just doing things that are very primitive and very basic. Goshika here says, I think select all students should not link to update students processing service. Well, how are you going to determine if a student exists or not? Right, so you're basically hitting a query, right, and you're selecting based on particular parameters. And if that student exists, then you basically update it. And if it doesn't exist, then you modify it, right? Or add it. Okay. Let's go back here to this. And let's do that. Let's see here what does this imply? We need to create a new branch here. So I'm just going to go ahead and say users, San Habib processing, right? And this is retrieve SQL query. So that's our branch here. And then we need a new category in here. So I'm just going to create a new folder here. I'll call it processings. And under that, I'm going to call AI. So it's still an AI service. And then under that, I need an interface. And this interface will be called AI processing AI processing service. Okay, let's add in the copyrights in here. And let's define what we expect to come back from this thing. Okay, so this guy is supposed to give us a string. So we're passing in a string, and it's going to give us back a string. But the strings that we're passing into this guy are a little bit different, right? Because I guess the question here would be if Milan actually converts the statements that are coming from the information, the database schema, basically the table name, the column ID and name and all that, and data type and all that. This is coming from a processing service on a SQL side, right? We need to somehow pass this over to this guy, right? So what would that look like? Let's just say here, we know that what needs to come back is string, but we're going to go here and say retrieve SQL query async. right? And what we need is basically a list of something like a key value pair. That's really what we need from the SQL side, right? So do we do a list of a tuple like this that basically tells me here is your here's your list, and this is our table information, like that, and then underneath that will be like the natural query. What do you think, Omar? Does this work?
So basically here we're looking at the data one will give us the table structure, right?
Yeah,
And
so it's,
you wanna
yeah,
yeah,
go ahead.
you
So
wanna
it's,
you wanna pass it here to the foundation AI foundation service to oh sorry, you will make the prompt here, right? You'll create the prompt
yeah, so the processing
based on this
services,
table information.
yeah,
Yeah.
the processing service is going to call the foundation service, but the processing service is going to take the table information. So the table name, right? The table, each and every column in these tables. So let's say if you have, for instance, let's do this. If you have a table called students, right, then the key value pairs I expect to be, it should be, I think it should be a grouping even. It's not just a list of a tuple of a string. It needs to be more like a grouping kind of thing. So we need to know that there is an ID, and that ID is a unique identifier like this. If there is a name, we need to know that this is a var char max or whatever, right? Max is like 2 gigs, right? That, I really highly recommend people to kind of think about that because it reserves a space and memory for it. But, anyway, something like date of birth, and we know that this is a date time or a date time 2, whatever the SQL database kind of dictates, right? And then we'd expect,
Can we share the model? Because in that service there will be a table detail model, right? Can we
yeah.
share it with this one? Like table and table detail. So instead of using a tuple here with a list, can we just use that model that gets back from the other service?
We definitely could. I try to kind of keep the model um, the same within a particular flow, but it can definitely be shared if it makes sense. Just know that we're bound by a rule that says you can only work with one model and any primitive type you like, right? So either native or a primitive, local or primitive kind of rule. So you can't just have a method that says, oh, in here we're going to return a student, but in the next method we're going to return teacher within the same processing service. That's a bad design, because now you're coupling so many things. As long as you are sticking to one single contract, I think that would be okay, because that means the service is working with one single concern, right? So I guess that works. We just need to know. So let's let's do this. Let's go into the models here under a I will put it under data. And I'm gonna go here and I'm gonna say, or let's just call it, yeah, data. And then I'm just gonna go here and say table information, right? And every table information will have basically, ideally, we want to have a string, which is the table name, right? What is the model that I kind of agreed upon with? Let's pick up the models that we agreed on with
Yeah.
with Milan the other day. So let's just go here. GitHub. Let's go to entity intelligence. Here we go. And then we had an issue the other day, and we basically said run SQL query, retrieve tables and properties. Not this one. So this guy here. Nope, not this one.
The
There
first
it
one.
is.
Okay. Yeah.
Right. So we're gonna have a table, and inside the table there's a table column, right? And each and every table has some details in it. So that's basically the structure that we can copy over, right? And I'm just temporarily creating this, but he's gonna have to go solve that conflict, when he starts kind of pushing this through. because he's going to have, at some point in time, let's just say table column in here, and this is a table information, and he's going to have to kind of basically work with the idea of kind of mapping these models together. It should be a quick thing. It's not really a big deal, but you're just going to have to be cognizant when he's doing that kind of mapping there. Okay, let's move this over here. So this is a table column. I think this is totally fine. And then we can basically go up here and say, here's the header, Control key E. And these guys are internal still, right? You know, because your external consumer of this library doesn't need to know about that, right? There you go. Why is this guy complaining? Columns, table column. Yeah, that should be okay. So going back to this, I think what we're getting really from the orchestration service is a list of table information, right?
Yeah.
So he's hitting SQL. SQL is giving him back all the tables, right? And he needs to map that into table models with nested columns in them. And we're basically taking that information and we're baking it as part of our, there will be a lot more intelligence that we need to add in there, because imagine you're hitting a SQL database, and that's where most of the people that tried, like, by the way, this is not a very novel idea. A lot of engineers have already tried to do something similar to that. What broke them is that, or what kind of put them, discouraged them from continuing, is the limitation on the number of tokens that AI can allow. But also at the same time, like when you're actually working with a realistic, a database that has, I don't know, a couple of hundred tables in them, right? You start kind of wondering, how do I solve this problem? I know how to solve this problem, or at least I have an initial solution, but I think like when you crowdsource any effort like that, you kind of get through much faster and you come up with amazing solutions. Who would have thunk it, right? If we work together, we can do a lot of crazy things. So okay, if that's the premise here, right, then we need to basically go and create a service. So AI processing service, like that. And this guy was going to implement AI processing service. You do know why we're making all of these internals, though, right? We did talk about this a little bit, did you?
Like, we only want to expose the exposers, right? So
Yeah,
not
exactly.
anything behind them. Yeah.
Exactly. Okay, private read-only IAI service, I think, because that's the service that we care about. So it's our AI service. By the way, I'm not very happy about the method name that we chose, because the method name should still be primitive, and we said SQL, even though there's nothing about this that is supposed to be SQL. So just to kind of put my own mind at ease here, I will say prompt async, prompt query async. Watch what I'm going to do. If I just say rename all like this, all my problems are solved. How
But
cool is that?
why actually SQL makes sense to me, because later if we have another broker for NoSQL, we'll have another foundation and processing service for that. But this is actually just SQL, right?
What's in here relevant to SQL in this implementation?
Oh, okay. Here, yeah, like for the completion, it doesn't matter. Here, this one, AI
Exactly.
broker, it just calls anything. Yeah. Okay, I
Exactly.
got it.
In the NoSQL situation, I think the difference will be mostly on the database side, right? Not the AI side.
Yeah.
The AI side will just need to say, I guess the AI side will just need to tell OpenAI, hey, this is a query for this particular platform. So that's the only difference. Okay, cool. So now I'm much more happier, because now I can basically go and say, yeah, this is actually a primitive operation like that. Okay, cool. What do you think is the next step here? We should probably, We should probably go and write some tests, right? Because, or should we write the implementation here? See, it's so easy. I could just do this and then just say prompt async and pass in the natural query, and it's all done, right?
Mm-hmm. Yeah.
Like, why do we have to spend 2, 3, 4 hours on our writing tests when we could just, just get it out the door, What does Gregory
No,
say?
it's not.
Then a MongoDB broker. Yeah, each and every one. Well, it wouldn't be brokers next to each other. It will be like different libraries that target different platforms. So it will be standard AI entity intelligence.sql, standard AI entity intelligence.mongo, and so on and so forth. Something like an extension or something. So we can build a core piece, and then people could build extensions on top of that core piece. As long as you're feeding me the right information that I need to do the AI part, then we should be good. I think we're very, very much so going to do it this way in here, which is naturally might change how this library is structured a tiny bit, but I think that's okay. What were you saying, Omar?
No, you were saying like, why do we spend that much time writing a test?
Yeah, my man, I could just go up in here and just say await, huh? And I could just go and say, this dot service natural query, and here you go. Why are we complicating things, Omar? Why are we making things harder for ourselves?
I know it's a trap, but yeah, it's not about the current state. First of all, it's about the future state mostly. Like changes will happen over time. So plus, like thinking about all the edge cases before writing. Now, yeah, it's actually a very simple implementation, but maybe thinking about all the edge cases while we're writing test kind of makes it more robust, I guess.
Yeah, I agree. But can't we just do it this way now and then later we come back and do it right?
Sure, if you want. I think there is a different answer here.
All right, man. It's cool. I'm just kind of, some of the things I heard in the past, I think software engineers should not, like, every time you're gonna hear a software engineer say, "Oh, let's just do it this way now," and then we're gonna go back and do it right later. There's no later. Later never comes back. There's no such a thing as later. Do it right the first time and move on, because once you're done with one piece and you're demoing it, in addition to the part that you will be just kind of attacked with more things that you need to do, right? You just won't have the energy, to kind of build, go back and do it. Very, very rare, very, very rare amount of people that will actually go and do that. Okay, my friend, cool. So we have AI processing service in here. So it's AI processing service. Great, great, great. Like that. And then we need to kind of set up our test. So this is the mock. Here's mock. And then this dot AI processing service equal new AI processing service. And this guy takes in an injected, we need to inject service like that. What happened? We didn't pass in the parameter to it? Well, that's a surprise. Tests. That's my bad. I basically named the thing. So there's this guy, and this should be tests, right? So processing service tests like that. And then this guy should be happy now. So this AI service. There you go. This dot AI service mock object. Okay, and now here comes the fun part. How do we go about creating or generating this random input, right? I want to pass in an input that matches the situation that we have here. By the way, this guy should be value task because it's an awaitable, contract. So we should probably fix that part. And we also should do the same thing in here. So this is value task in here. And that will basically retrieve SQL query. Yeah, now this guy is specific about SQL because it literally says, give me SQL information, right? Versus the other one that just says prompt the AI with whatever you want to pass in. Okay, so going back here, we need to generate the inputs for this. We need to be able to go and say, here's a bunch of inputs that are randomly generated, and we need these inputs to match a certain structure. What I'm trying to say is that when we prompt the query needs to have a certain structure, something like whatever we pass to it, we should say, given the following SQL Server schemas, right? And then we basically go and say, students with the following properties, right? And then we go and say ID is a unique identifier, and then name is a varchar, 10, or whatever the case may be. You keep going like that. So you need to do all of that in the prompt. So the prompt that you're sending to AI needs to take that table information and prompt that. But then after that's all and done, and then you basically, so this is table students, and then table teachers with the following properties, like that. And then you go and say, well, the teacher has an ID, which is a unique identifier as well, right? And so on. And then convert the following natural query into SQL query, and then in here you pass in your natural query. That's the goal. That's what we're really trying to achieve here.
Yeah.
So this service needs to generate that statement and then send it to AI.
Does it make sense to have the prompt in a different model as well, where we have the information and maybe override it to string to return all this kind of concatenated text?
Well, that's what this processing service does. That's its only responsibility. What else is it doing other than that?
Yeah, so yeah, we can just like in a loop here, loop through all the tables and just construct this string basically, yeah. Okay.
Yep, it's literally processing. That's what processing is. You're doing something a little bit of more than just calling a dependency and validating information. You're calling dependencies, validating information, and doing processing. That's why it's a processing service.
Mm-hmm.
Now, the
So
most
now
interesting.
the
Go
question
ahead.
is how we generate this randomly, right? You say?
Yeah,
How
there
generate?
you go.
Okay.
So anybody, or at least the majority of people, like, how there's already a smaller set of engineers that will actually write tests for their code, right? A lot of people just go, hack in and push something out there. Out of that small set, you will see people that repeat the same business logic in their tests. You know what I mean? Like, for instance, if I go and tell you, hey, how do you test drive a function called foo that returns x plus y? How do you test drive this? What would be your test looking like? What do you think?
Yeah, so like we shouldn't pass like 5 and 6 to the parameters. First of all,
Right.
like make it random. So
Okay. So
yeah.
so let's do this. Let's do this together, right? So int x equal random int, right? And then maybe int y equals random int, right? Okay. How do you create the expected value? So int
Without saying
expected.
x plus y.
Aha. Why is it important? Because you can't repeat your business logic in your test. So how do you do that?
Yeah.
By the way, this is just a discussion. I'm not really putting you on a spot
Yeah,
and kind of quizzing you. We're just talking. You know what I mean?
yeah. So because they are random already, we don't know the expected. So we need kind of to find it in terms of x and y here, right?
Mm-hmm. Mm-hmm.
But not x
Yep.
plus y. Yeah.
Yep. You have
Maybe
to.
have
Mm-hmm.
yeah. We need a third. Yeah. You go ahead. Not in the right time.
So there's this rule in test-driven development. Something that you know, I had that's inspired from Euclid's law of axioms. Euclid's law says things that are equal to the same thing are equal to each other. Euclid's law, right? What that basically means is that if you create, you know, two different sets of things that are supposed to be equivalent to each other, you're letting your business logic make that determination in terms of whether, you know, it's supposed to be getting to that particular result or not. I personally, and this is the most minimalistic kind of example for all of this, I would personally go and say, here is my random result. So you're generating the random result in here, right? And you're basically going and saying, my y is basically x minus random result, or random result minus x.
Yeah.
So you're coming from the other side.
Now, yeah.
You didn't do an addition here, right? But you got to the same result from a different direction. And this is the most, while this seems like a very simple, this is actually the hardest of them all, because you're basically going and saying, you know, how do I write a successful unit test for this without having to repeat the business logic that my method is doing? So you have to go from a different angle. What I usually tell people, just to kind of simplify, you know, this law, is basically your logic goes to the result from that direction, right? Your test goes the other way around. Your test is going from, it starts from the result and then it works its way back. So this is here your test, like this, and it's actually working its way back from the result. You see the difference? Like they're meeting each other at the result. Your logic will say x plus y equals result, right? Your test will say result minus x equals y. So working back from the result to the inputs. What's this has to do with anything, right? How does this apply in here? What, right? You're here in a little bit of dilemma, because you're in here coming in and saying, check this out. You're basically saying that you need to generate values that match this guy, but these values need to also be independently generated for the expected result. So you need to get to the expected result, and you need to get to these tables informations from a middle ground. Something dynamic that has to be generated, and this dynamic thing is the one that's going to distribute these values into these different realms, and then you let your method or your business logic handle, you know, reaching out to that result. Right? How do we do that? Well, as soon as you hear me talk about Euclid law of axioms, imagine immediately that I'm going to go and say, I'm going to use dynamic things. So private, static, list, I grouping, right, of a string and dynamic objects, like that. Right? So what this is basically saying is that here's your, here's a list, right? And this list has an I grouping, right? And here's like a key, and there's a bunch of information that will go in there. Right. I guess it doesn't, like this one doesn't necessarily has to be dynamic. We could just go and say, here's a list of things that will go in there. Right. But somehow these things need to be a tuple. They need to be, you know, two things, because we're going to construct that table information from one side, and we're also going to construct the result from the other side, and then let the business logic kind of reach to that result on its own. This is also an advanced topic in this test-driven development. So if your head's spinning a little bit, that's natural. That's okay. right? So this is a bunch of primitive models. You know, we still need, so this would represent the table name, right? But we still need a column name and a column value. So maybe a tuple in here is better, something like this. Yeah, maybe a tuple in here would be better for something like that, right? And we're basically going here and saying, generate table, random table information, tables information. Right? The rest of this is the easiest thing in the world, right? Because we basically need something to generate this for us randomly, and something that generates this for us randomly, and then iterate and iterate and iterate. Right? So how do we go about doing that? So here's a private static string, generate random table name. Right? So this will say mnemonic string, like that. And we're basically just saying get value. So this will literally just generate a completely random string. Right? If I go and say generate random string like that, this will kind of do the trick for me. And I also need a number. So how many times do I want to iterate? So private static int get random number, right? So this here will be new int range, minimum of 2, maximum of 10, exclusive, like that. This needs to be static like this. There you go. So now if I'm generating this, let's say it's table by table, right? So I want to generate literally table by table for each one of these and then spit all of that out in a thing. So if I go and say private I grouping of a string with a list of tuples of a string, there might be a better data structure for this, but let's just say generate random table. Right? So what do I want to do here? I want to go and say random table name. Here's get random string, like that. Why is this guy tripping? Because it's not static, right? There you go. Since it doesn't hold a state, it should be fine. So this is that guy. That's the table name. And then we need to iterate the number of columns. So it's a random column number. So here's a get random number, right? And then I need to start iterating this way, right? So I'm supposed to return a list of a tuple for this, right? So, okay, so there's list, tuple, string, columns, list. Here's our guy. And then I'm basically going and saying for, well, I could do this a little bit cleaner than that. So let's do it this way. Enumerable.range, right? And then you're basically starting from 0. And then the count is get random number. So that's what we called random column number or column count. Let's call it column count. It's better this way. Here you go. And I'm putting this count in here, right? And then I'm going and saying for each one of these, do a select, right? And out of this select, here's your item, create a new tuple like that. And this tuple will take 2 strings like that, right? And we just need to kind of create the first and second value, right? So these are just get random string, get random string, get random string. Sorry, generate random string. I should probably call it get random string. Right, so now you generated a list of tuples that are completely randomized. Right, now the last thing I need to do is just go and say .toLists. We're done. Or something to that effect. Why is it tripping? Let's see here. This is the tuple. Here you go. Got two lists like that. So this will give me this column list. Now all I have to do is just return new grouping, I guess, something like that. How do you create these grouping things? Let's see. Grouping, C# create. Let's see. I know that you can produce them when you say group by. I know that. But how do you actually create a group from scratch, if that's even possible? Let's see how we're gonna do it. Yeah, let me bring this up here because this is not something people do every day, so we need to kind of look this up real quick. Let's see here. So C# initialize grouping. Is that even possible? Great. If you really wanted to create your own grouping, blah, blah, it is simple interface to implement. Oh, we have to implement an interface? Don't do that. I don't want to do it this way then. Maybe a dictionary? Maybe a dictionary. A dictionary would do the trick instead of grouping. Fine, let's do dictionary instead. So let's go here. Dictionary. There you go. And the key has to be unique anyway, so we should be okay. So this will be a new dictionary, right? And it's basically written the whole code for me for it. Cool. So this is a dictionary that has a string with a list of key value pairs in it. Does it make sense to have a dictionary of a dictionary? That would simplify things a little bit. Like this, dictionary of a dictionary. So that would be we wouldn't even need the list anymore, right? Because it's already a dictionary. Well, it's key value, so we still need the list. Yeah, I think that's okay. And then I basically need to go here and say, change this into a dictionary like that. And then let's take this guy and put it in here. And then for a dictionary, we basically want to be able to let's see here. So you have a dictionary of a string, and then inside of it, there's another dictionary that has key value pairs. So why do we need the list? We don't need a list anymore because you already have that. Yeah, that might be a little bit cleaner then. So throw that list away. And we're basically just adding key value pairs for a dictionary like that. I think that would work, right? So instead of doing that, we'll just say new key value pair like that. So this will go here and basically do something like this. Like that, maybe. Right, so you're basically taking a range and you're adding, I mean, you could even do, let's see here. If I do for int I, I'll probably clean it up in a second, but I is less than or equal random column count. And I is incrementing, right? We basically want to generate a dictionary that has the key values for every column and the data type for it, right? So it makes sense here if I went and said dictionary string columns. And then in these columns, I can go and say add, and here's your key and value pair. Just need to make this a little bit cleaner, right? This is too basic, right? But then at the very end here, I can basically go and say, okay, so here's my new dictionary, and this new dictionary that I have here, table dictionary equal new dictionary like this, and I can basically return here and say here's here's the table dictionary dot add, and the key is the table name, and the value is basically the columns dictionary like that, and then I'm basically returning this guy here. Right now, why is this guy angry? Let's see, table dictionary, because this guy needs a dictionary within it, yeah, something like this. Yeah, something like that. Okay, so this is going to give us the table name, and then it's going to give us every column and the column type inside of it. Right? Now, if I do it this way, then that basically means I need to let's say this is columns dictionary, just to be kind of consistent. Yeah, and then what are these guys take? They take key values. So here's a key. Here's a value, basically, like that. Right, so this will be the table. For each and every one of these, we will have, the column information, and then in here I have the table, and then the columns within that table. And then that guy up here will basically be a list of dictionaries that have a dictionary string, like that. So this is basically is going to give me all the random information for, now all I have to do is just repeat that a couple of hundred times or however many times. So this is tables counts, right? And this will take a random number like this. And then I can basically generate my list. So I can basically say return enumerable range table count, and then I'm basically saying select and then generate random table information, got to list, like that. And this needs to be item because it's really just a generic item, right? And we promised, we said we're going to return a list of a dictionary of a string dictionary, which is what this guy generating. Why is this guy tripping? It's basically cannot implicitly convert type collections dictionary to that. Do I need to explicitly say this is a list of dictionary of a string to dictionary of a string? It's telling me I already know that. What's new? Let's see here. Yeah, I guess, let's see. Oh, I'm calling the wrong thing. That's why. Where's my pairs? You guys asleep? What happened to you?
No, silly question I have is I know this kind of intermediary data structure, but what's actually the harm if we use the model that we used there? Like if we
You'd
use the, yeah,
you'd be repeating the business logic. You'll
but
basically be.
I said the model only, which has a table name and a list of columns instead of of dictionaries and stuff, right? Like if I use the model, is it business logic? The business logic is actually what's happening in the processing service.
Well, you're gonna generate that values with that model, right?
Yeah.
You're gonna generate values, and then what are you gonna do with these values? You're gonna convert them into a query, because that's your expected, right?
Before, actually, I just meant what you did right now, which basically you generated the data. You didn't generate the query yet, right?
I know, but what are you gonna do with that data? Like, let me explain. Like, let's say you generated a list of table information, right? That's the model that we worked with, right?
Mm-hmm.
What's the next step? What are you gonna do with that? You're gonna need to generate expected query.
Yeah, which is a repeating of business logic here. I mean,
There you go. That's the problem. I told
I'm,
it's a little bit
yeah,
of an advanced topic, but yeah.
yeah.
Go ahead.
I don't know. I just want to like see how this. What do you want to do next now to not generate it by hand? Yeah,
Exactly.
yeah.
We created like this list of dictionary to dictionary string. We need to generate both the table information and the query independently.
Mm-hmm.
That's the equivalent of us going and saying generate result and then go and say result minus random. That's your X, and also result minus random, that's your y. Something like that. Right? That's literally that. That's what this Euclid law of axioms is. Things that are equal to the same thing are equal to each other, except that they're not getting to each other through the same path that your business logic is going to take. So in essence, if I really were to kind of explain this approach, you're basically saying, really generate this random blob of data, and out of this data, generate the structure of the input, and generate also the structure of the output. And then let the business logic make the connection between the two, like get to that result on its own. Right? So this is test generated, and this is your business logic. Oh. Doing the right thing is hard. I know the easiest thing for us to do is to go and generate the. Do you know how easy it is to just go and put that model in the randomizer and it will just generate values for us? The easiest thing in the world. But it's not the right thing. That's the problem. So your test is generating the input, which is in this case the table info, but it will also generate the query. And your business logic is responsible for taking that info and turning it into the query.
When you say you want to generate the query in the test, in the test file there, you will go and actually concatenate the strings as well,
You
right?
must, yeah, you have to. But you're not concatenating from a table info, which is what the business logic is going to do.
Yeah, okay, that's the difference. Like it's where you're getting your data from, basically.
Yeah. This is literally the equivalent of me saying generate result and then generate X and subtract X from result. This is the exact same thing. Right? So your test just stops there. Your test basically says, I'm going to give you this and this. Your business logic will go and say, yeah, my job actually is to take this input and actually convert it into this output. See the difference? Like this guy is giving you both. This guy has to take this and actually turn it into this. All right. So, there's a bunch of videos where I talked a little bit about this, Euclid's law of axioms. It's a mathematical equation. It's ancient. It's before any of us was born, but it's before even Abraham Lincoln was born, I think, but it's definitely something to look at and something to consider, right? So the next step, I'll let Kailu do this next one because it's the hard one, but maybe tomorrow because we're at time. But basically, Kailu, what we want to do, you know what to do, right? So we're generating random tables information, and we want to map this stuff into two different things: a query, but also which is going to be what's our expected input, and then a a table information, which is our expected input for the method versus expected input for the dependency.
Okay.
We'll do that tomorrow. Okay. If you guys want to kind of just learn a little bit more in a more focused session about what is Euclid's law of axiom and why is that important and why did we even start going down that path, I really highly recommend kind of looking into, give me 1 second here. I'll tell you in a second. Yeah, there's this really nice session here where I basically talk to Ricardo Cruz about Euclid's law of axiom. I literally take the whole 34 minutes to just literally talk about, of course, we were talking about it in a UI perspective, but it applies everywhere. It really applies anywhere you want. So I'm going to share this link down here in the chat, but really highly recommend people kind of take a look and learn about that pattern. Okay, friends, cool. We continue tomorrow. Before I do that, let me kind of put a commit here for this. So I'm basically saying here, should retrieve SQL query async. And this here, look at this, WIT. That means I don't even have a failing test for you yet. It's all driven by these tests. Okay, friends, cool. We'll meet tomorrow. Good.
Thank you. Thanks.
All right. Thank you all. Talk to you later. Take care.